agricultural 4.0. As we are talking industry 4.0, agriculture is the industry. Agriculture has become today industry, and this is not my title. You can see so much amount of literature on agriculture 4.0 and precision farming. So much amount of advanced technology is used in the agricultural industry today. So in recent years, the use of technology in agriculture has gained momentum of which GIS, Geographic Information System, satellites, air vehicles, autonomous robots, GPS and various other communication technologies have made their way into farming. So with the innovation and implementation of such technologies, new terms like precision agriculture, precision farming, precision approach and digital farm and agricultural 4 has come to the horizon. This precision agriculture is the information and technology based agricultural production system used to analyze, determine, manage field factors like spatial, temporal viability for obtaining maximum sustainability, profit and environmental protection. Ultimately, we must save our environment. This precision agriculture paves the way to make efficient plans for pest control, harvest, irrigation, disease control, and optimum fertilization. And various platforms are used in this agriculture 4.0 for remote sensing like aerial platforms using planes, helicopters, drones, balloons called as hot balloons earlier days, spatial platforms, satellites, and for sensors for measuring reflected and emitted electromagnetic radiations. Of course, today satellites and drones are most commonly used tools for precision farming. These are the various areas where the remoteless piloted vehicles, drones can be used in the agricultural area, exclusively in the agricultural area. So disease surveillance, irrigation, advanced sensors, nano sensors, smart sensors equipped in the drones, they can be used in the agricultural industry for all these areas. Irrigation and fertilization, soil and field analysis, weeds management. They take the pictures of the crop condition with the sensors available in the drones and other air vehicles, and they can see all these conditions. So planting crops and trees, mechanical pollination, all these things. So before going to conclusion, I would like to share a few videos that are related to this agriculture 4.0 precision farming and application of these drones in spraying the fertilizers, because in India we have various types of agriculture. Subsystemic the agricultural system where many of the farmers, we have only limited agricultural land, 1 or 2 acres of land. If we apply this technology, the sustainability is not possible, cost is more. But when we apply this technology on communal basis, when government take initiative, for example, if a government supplies the drones and all these things for a particular village, then spraying these fertilizers and all these things at a time within an hour, hundreds of acres of land can be sprayed by these fertilizers with the help of these drones and others. So that technology updation and government cooperation is needed. But in India, we have various types of agricultural system. If you see the Tamil Nadu, Karnataka, Kerala, mostly these subsystemic agriculture system where limited land is available. But these dry farming, wet farming system where, and similarly in hill areas, some northeastern states, Manipal, Nagaland, other Himachal Pradesh, in those areas where the paddy growing like in Andhra Pradesh, Tamil Nadu and Telangana states is not possible. Their main area is growing the plantation, the trees and the forest, this gardening, etc. The mango fruits and the apple fruits, etc. And the spraying of all these things, fertilizers for hundreds of acres at a time is very useful for the plantation purpose. So, and this of course in the rural areas also, the small size drones which are available for 1 or 2 lands, they are also used by the farmers in certain applications in Andhra Pradesh and Tamil Nadu and these Telangana states also. Yeah, Raju sir, I would like to share video.
Okay, sir. Go ahead.
this video.
Yeah, is it visible, sir?
Yes, sir. Yes, sir.
Okay, thank you.
Agricultural Drone 2020. These are the best drones for agriculture. Drones have become essential in agriculture since they help the farmers gather more useful information about the water, fertilizer, seeds, crops, and more. Drones give the farmers a better view, both figuratively and literally, of their resources in order to utilize and expand more wisely. Keep watching now. DJI Agrism G1 Agriculture Spraying Drone. Agrism. Each battery can cover 6,000 to 10,000 square meters. Therefore, in 1 hour, MG1 can cover 24,000 to 40,000 square meters and 4 batteries are needed. The Agrism G1 from DJI, created for the management of crops with a loading capacity of up to 10 kilograms of liquid and a maximum speed of up to 8 meters per second. The DJI Agrism G1 has been created for crop management, is autonomous and 40 times more effective than manual fumigation. It incorporates a spray system with a capacity of up to 10 kilograms of liquid, specially designed to achieve the highest efficiency in the fumigation of products for the care and management of crops. This drone has been created to be above all resistant to all kinds of inclement. It is able to operate under the lluvia and to resist the corrosion caused by the merchandise that it will generally carry. With capacity to load more than 10 kilograms of liquid for fumigations, it can cover in an hour up to 4 hectares. This makes it an appliance 40 times more effective than manual fumigation. The Agrism G1 can reach a speed of up to 8 meters per second while adjusting the intensity of the spray to the speed of the flight to achieve uniform coverage. DJI Agrism G1 Agriculture Drone uses a nozzle system to spray the product that loads into its tank. Consists of 4 replaceable ceramic nozzles, each powered by a motor. The useful life of the nozzles is very high. During fumigation, the airflow generated by the down motors increases the spray speed and ensures that the product reaches the entire plant. Microwave radar, Parrot Bluegrass Fields quadcopter. The Parrot Bluegrass Fields quadcopter for agriculture is a crop mapping and analysis tool that can quickly provide actionable data to farmers, retailers, insurers, and anyone else who works directly within the agriculture industry. The Bluegrass Fields obtains its information via 2 included sensors. There's a 14 MP visual sensor that's capable of taking high-res photos and capturing video at up to full HD 1080p 60 quality and more precise pictures of crops such as strawberries, blueberries, or grapes. 3 batteries are included for a maximum flight time of approximately 75 minutes. While out in the field, its carbon fiber construction helps to ensure it can withstand the elements. DJI Agrism T16 new model precision spraying custom drone. The T16 can spray up to 10 hectares, equipped with the RTK plus GNSS dual redundancy system. It is not separated by version. The T16 has a maximum flight altitude of 30 meters. While it may cost quite a lot, the DJI Agrism T16 is a great investment if you need the most accurate data gathering via sensors. Its 4K camera can spot data within just a few seconds under acres upon acres of land. The most unique feature about the DJI Agrism T16 is that it can live stream the data directly to you, whether it's crop health, the number of crops, humidity, or anything that you input that is relevant to your business. The DJI Agras T16 can get it done without any problems. You know what they say, it pays for itself. Let me know what you think of this video in the comments. If you like this video,
Precision agriculture is a method in which farmers optimize inputs such as water and fertilizer to enhance productivity, quality, and yield. The term
Is my
also
video,
involves minimizing
coming,
pests
sir?
and diseases through
Yeah, it is
spatial
going, sir.
application of
Raju, sir.
precise amount of
Sir, it
pesticides.
is going, it is audible and right.
we'll deal with
Hello?
Yeah, is it available, sir? Video?
Available, sir, but now it is stopped, sir.
Okay.
parts of your field in an appropriate way, in different ways, because these different parts of the field, they are different. The soil may be different a little bit. The sun which is being received by that field, part of the field may be different. The slope may be different. So there is varying factors varying across a particular parcel. Taking those into account in order to maximize the crop and taking ecological factors into account.
So what exactly is precision agriculture and how is it different from traditional farming?
The traditional agriculture where everything has started. This is actually from experience handed over. Technology has also improved. So they started with animals in the beginning. They built up machines, tractors, and so on. And then they realized, okay, if I'm more precise on planting, harvesting, fertilizing, then I actually get also more out of my field. And this is exactly difference where precision makes the difference in the efficiency or in the productivity of a farm. And this where precision agriculture is actually only a driver or measure another level of productivity in agriculture.
Precision farming is a farming management concept based on observing and responding to intra-field variations. It relies on new technologies like satellite imagery, GPS, information technology, and other geospatial tools. Let's try and understand this better. Suppose you have 20 hectares and you are getting 100 tons per hectare of yield. A remote sensing image of your field shows the difference between the yield in various parts of the same ground. Areas marked in red show the yield of 20 ton per hectare, while areas marked in blue show yield of 120 ton per hectare, a difference of 100 tons. Or in other words, not optimizing yield from these 100 tons is leading to loss in productivity. Observing variability in crop is the first step of precision agriculture process. Evaluating all this information together can give you a better understanding of the causes of variability in your farm. Depending on evaluation, you can manage your crop better. Sensors in field measure the moisture content and temperature of the soil and surrounding air. Satellites and robotic drones provide farmers with real-time images of individual plants. Information from those images can be processed and integrated with sensors and other data to yield guidance for immediate and future decisions, such as precisely what fields to water and when or where to plant a particular crop. For example, it can give you an idea if you need to apply a particular mineral or fertilizer in one area of your land rather than using it in the entire farm, thus saving your money, resource, and time. Geospatial science has a major role to play in securing both food and nutritional security in agricultural systems. Geospatial technologies such as GPS, GNSS, remote sensing, and drones play an important role in precise location of problems, optimizing resources, and maximizing yield.
This is higher precision GNSS, which actually only enables a 1 to 2 centimeter accuracy to really bring this precision also down to the field, to the crops, where they actually need it to get the productivity. On the other component or the other technology that need is also, of course, also the machine together with the tools that you have in your bag, that they are adjusted and calibrated to each other, because the positions that you measure on the roof, it's not what the farmer is interested in. He is interested in the centimeter on the ground down there. So you have to know what is the distance between these 2 points to make it really precise as an entire thing.
Unmanned aerial vehicles or UAVs allow farmers to monitor crop and livestock conditions consistently by air to find problems that would not be visible in ground level spot checks. An apt example, a farmer can inspect whether his crop is not being properly irrigated through time lapse.
So we're also seeing increasing growth in agriculture. So that's using different sensors like multispectral sensors to basically fly over the crops and measure the reflectance of the light, seeing where the crops are healthy and where they're struggling.
Today, mobile apps, smart sensors, drones, and cloud computing make precision agriculture possible for farming cooperatives and even small family farms.
Yeah, that's all about my presentation. So these are the conclusions. Am I audible to you, sir, Raju sir?
Yes, sir. Yes, sir.
Yeah, these are the conclusions. Sustainable manufacturing is the most important aspect to be considered by all production engineers, not because it is a fad, but a necessity as an obligation to the world we live in. In the field of agriculture, nanotechnology has been used to heighten the crop production with quality enrichment by improving farming systems. In sustainable agriculture, the production of the environment from pollution is the crucial target for trade, and nanomaterials provide an assurance of better management and conservation of inputs to plant production. Thus, the potential of nanomaterials encourages a new green revolution with reduced farming risks. So, these are some of the references I have taken from the literature. And these are some of the journal papers you can also download. They are available in the Google by typing these titles: application of nanotechnology in plant growth and crop protection, remotely piloted aircraft in agriculture, the pursuit of sustainability. They are available. They are not from the they are available freely. PDF files are available. You can also download if anybody is interested in this area of application of nanotechnology in agriculture. So thank you all. Thank you all. Any questions, queries?